Alright everybody, welcome back. We are continuing our fractals presentation. Our next presentation is fractals in medicine, and our group is Melissa's group.
Thank you for that introduction. In my group, there is me, Ishmael, Lois, and Esme. Ishmael could not make it due to personal factors, so we're going to go ahead and start. Fractals are a mathematical construct that shows self-similarity over a range of scales and non-integer fractal dimensions. Owing to these properties, fractal geometry can be used to efficiently estimate the geometrical complexity and irregularity of shapes and patterns observed in lung tumor growth over space or time. The lungs are an excellent example of a natural fractal organ. If you look at the tree upside down, mouse over the image, okay, you can see that the lungs share the same branching pattern as the trees, and it is for good reason. Both the trees and lungs have evolved to serve a similar function, respiration. Since they perform a similar function, it should not be surprising that they share a similar structure. In the lungs, blood vessels have a very precise relationship with the epithelium. Pulmonary arteries run along the side and branch with the conducting airways. Relating to blood vessels, I'll go ahead and pass it to Luis.
Hello guys, so I will be talking about blood vessels and how fractals is like blood vessels, like because it's a never-ending pattern. So as you can see, our body contains 5 liters of blood, and we have over 60,000 miles worth of blood vessels in us, like if we were to stretch it out. So how it works is the heart pumps out blood to the arteries, and it goes to the veins, and it just comes back to the heart. So we're always constantly, like, blood is always moving inside of us, like always, even when you're sleeping. And then, for example, if I were to like poke myself right now, I'd just bursted up a blood vessel. Also, so let's say you're walking to the restroom and you accidentally smash your shin, and you see a bruise. That means that that's internal bleeding of a blood vessel. Also, let's say you're speaking to an attractive girl and you start blushing. That's your blood vessels expanding. And one thing with keeping a good blood vessels like healthy, you gotta like eat healthy, you gotta exercise, pretty much take care of yourself. Because if your arteries get clogged, that means it's a wrap. You got a heart attack. So you know if you did or not. And now I'm gonna pass this on to Esmeralda, how she's gonna explain fractals and her topic.
So as Louis mentioned, that fractals is a never-ending pattern. If you guys look closely to the palm of your hands, there's actually patterns around your fingers, your palm of your hands and your fingers, and just from your head to your toe, just like never-ending patterns. And that's the same thing as the inside of our body. And specifically, I'm going to talk about the nervous system, but I think it's better if you have a visual, because me personally, I'm a visual learner, so I'm going to let you guys watch this video.
Oh man, look, is that a buddy? Yeah, I hear it too. Out. How am I going to learn about the nervous system with that?
Slow cab at your service. Listen, we're here today to talk about the nervous system.
Hey, wait, hold up, stop the song. Something big. He's landed on your arm.
How does your brain know what your senses feel, boss? It's your nervous system getting the job done. Don't think you have nerves in your skin, well, you're wrong. And nerves are made of bundles of neurons, specialized cells that carry messages fast, believing that they don't even need a messenger bag. Most nerves connect to the spinal cord, and its mission is to act like the line back through motor neurons, shifts your brain so your reaction's fast. That's the somatic system and its various tasks. It's another crucial part of the PNS. The most involuntary actions get done by the autonomic nervous system. It's active even when you're still or asleep. Imagine it regulates the body's internal machines so your heart always beats and you always breathe. It's in charge when you cough or sneeze, when your pupils expand in the dark to help you see.
Chilling with the systems, I'm like, oh hey, who's this with the neurons, spinal cord, and brain, controlling everything, got they do and feel.
That's the nervous system, y'all, you know the deal.
Chilling with the systems, I'm like, oh hey, who's this with the neurons, spinal cord, and brain, controlling everything, got they do and feel.
That's the nervous system, y'all, you know the deal.
Got it. Right. Now, what were you saying about the nervous system?
You're gonna have to rewind that.
Yeah. So if you guys seen just how the body looks like right here, it's basically like a fractal. Like I said, it's a never-ending pattern. Yeah, that's all I'm saying for that. So I'm going to switch this out to you guys. The introduction of fractal geometry in the neurosciences has been a major paradigm shift over the last decades as it has helped overcome approximations and limitations that occur. In relation to trees, it has a never-ending pattern and nervous system. And this is basically like just part of your, forgot the name, but yeah, I was gonna explain that it's kind of something like this, and it's in the back right here. That's basically our whole nervous system down right here. You guys can see that right here, but yeah.
Your medulla, is that what you're talking about? Medulla oblongata?
What?
Never mind.
I think she's talking about the cerebral.
That would, okay.
Okay, so here's my slide regarding the brain and how it relates to fractals. I'm going to slightly touch base on the brain. Nerves that connect the brain with the eyes, ears, nose, and throat, and with various parts of the head, neck, and trunk are called cranial nerves. The human brain comprises approximately 100 billion neurons. It is the fractal branching pattern of these neurons and axons and dendrites that allows them to communicate. Dendrites. That allows them to communicate with so many other cells. Brain applications. The first application is the fractal analysis. Further studies have confirmed that the fractal dimension correlates with the increase in morphological complexity and neuron maturity. Fractal analysis was applied to anatomical, histological images and high-resolution magnetic resonance images in order to quantify developmental complexity of the human cerebral cortex, including things like epilepsy or some brain kind of disease. The intrinsic cardiac nervous system is also known as the heart brain, which is basically, in our sense, since we're learning IT, the vagus nerve works as IP addresses and MAC addresses. So as they transfer to each other, that's how they communicate from your brain to your heart, how you get a sense of feel and whatnot. Fractal heart, based on a healthy heartbeat, has a fractal pattern which can help diagnose patients with health problems sooner. Other than that, I believe we are done. Any questions?